Okay, last question then, the question 3 on the second order differential equations. I'll just start you off on this one because it's pretty well the same as number 1. In fact, you're not asked in this one to represent it in terms of r sine theta plus alpha. You've just got the particular solution at the end. I think you can see by looking at the answer that it's again a complex solution. So we're going to be following a similar method to the one we just looked at in number 1. However, I'll start you off because if we look at this, there's a shortcut to make it a bit easier for us. If I put in these values, we've got that I, which is 0.005, times the second differential of q with respect to t, plus k, which is 0.02 dq by dt, plus f, which is 0.2 q equals 0. So we can form our auxiliary equation, and we get 0.005 m squared plus 0.02 m plus 0.2 equals 0. And we can use the quadratic equation, the quadratic formula rather, as we did before. However, the fact that the right-hand side is 0 helps because I can multiply both sides by anything I like, and the right-hand side will still be 0. So if I want to get rid of these decimal points, I can do it by multiplying everything by 1,000. If I multiply it by 1,000, this 0.005 will become 5. So I actually get 5m squared plus, multiplying this by 1,000, moves the point 3 places, 20m plus, moving this 3 places, we get 200 equals 0. And if you look at it again, everything divides by 5. So I can simplify by dividing everything by 5. M squared plus 4m plus, what's that? 5, that's 40, isn't it? Equals 0. And suddenly we've got a much easier auxiliary equation to solve. So that's always something to look for, especially if you get really awkward decimal numbers. Right, see if you can carry on from there and finish the question off.